So, good morning, students. Uh, so today we'll see some of the classification of the manufacturing process. Okay. So the manufacturing process is mainly classified in four categories. First one is in casting, second one forming, and third one is in machining, uh, and fourth one is in joining. Okay, so in the casting there are the two. Once again, the casting is classified into two types. One is an expandable mold and second one is a permanent mold. In the expandable mold, in previous class only I have explained regarding the expandable mold details. Now let us see the which are the examples comes under the expandable molds. That's the procedure of the casting. First one is in sand mold, second shell casting, lost form casting, and investment casting. Now next is a permanent mold. In a permanent mold, the gravity die casting, pressure die casting, centrifugal casting, continuous casting. So say expandable casting and the permanent casting over here, they have been classified on the basis of the mold preparation. Okay, if the mold is been used for an refractoriness, or you can say the continuous same object is being used, or the same product. For example, if you take an sand, it can be expanded for a small or to an maximum size, small to an maximum size, or a larger size, small to an larger size. The sand can be used, but in the permanent mold, the die is been made by the metal or any of the object. It is been restricted to a particular area or the size it is been used. Okay, so that particular size, the casting model is been removed by the casting method. Okay, if you use the sand, you can prepare the larger size sand mold or the smaller size sand mold, due to which you can have the much more bigger casting product or the models by this method. That is why it is called as an expandable mold, and it is called as the restricted area where the metal dies are being used is called as a permanent mold. Now these were the examples: gravity die casting, pressure die casting, centrifugal casting. So these are the example of the casting process where the metal is being used, or the metal mold or the metal die is being used as an for the casting processes. Okay, now next we'll go for the forming. The formings are also, there are the two types of forming methods. One is in hot working and second one is in cold working. In previous class also I have explained regarding this one. The hot working is nothing but the high temperature on which the workpiece is been heated, which is above the below the above the recrystallization temperature, below the melting point. Okay, the workpiece is been heated and it is undergone to the desired different types of pressure to get the finished product or the desired shapes. Okay, now next is an cold working. The cold working is nothing but an work is a procedure in which the workpiece doesn't go under any kind of the heat treatment or the high temperature. It is been used only for the expansion or the differentials of the size to make or to modify the raw material into a finished product by having different types of treatments, or the procedure is there, different types of procedure of the forming. Now let us see which are the different types of procedures or the examples of the forming. If you consider the hot working, the forging is one of the best example for the forming. Over here the volume and the area, the area of the this one workpiece has been increased, and to get convert into a finished product, the forging is been used by the different types of hand tools are been used in the forging. In a open hearth furnace, the workpiece is been heated, okay, up to a red hot condition. Then the hot workpiece is been convert is been you is been applied under some heavy hammer blow, and the shape of that workpiece is being changed as per the dimensional to require as per the dimensional to require a finished product. Okay, so this is forging, and now we will go through the hot rolling. The hot rolling is nothing but an there are the two huge size rollers or the small size rollers. Okay, you can say the number of rollers are being used, okay, to convert a raw material into a finished product. So whatever the raw material is there or the workpiece is there, that is been heated in a furnace. Okay, the heated workpiece is been allowed to pass under this rollers. Okay, by the help of this rollers, some of the desired shape has been given under a huge pressure. These pressures are been applied by the rollers to get a raw material to convert into an desired workpiece. Okay, now next is an extrusion. So this extrusion is nothing but an external force is being applied on the workpiece to extend its original size or to change this original size. This is what the extrusion is there. Okay, from a small it is been used for making a small metallic wire for the extension purpose. Now next we can go with cold working. In cold working you can see the some of the few examples are there, that are the wire drawing, bending, shearing, roll forming, etc. Sorry. So the wire drawing, what do you mean by the wire drawing? The wire drawing is nothing but a small metallic wire you have seen, okay, for tightening anywhere where for the lifting of the service wire, electrical pole service wires are there. Okay, in your house you have seen normally they are been that small diameter, small thickness wires are doesn't require to undergoes to an heat treatment if the raw material is having an more mechanical property like a ductile. If it is having a ductile property, so when you apply some load for the extension, so it can automatically extend as per that load. Okay, for example aluminium, uh, copper. Okay, so these types of metals are non-ferrous metals are having its own ductile property which doesn't require to heat or to change its property for the extension. Okay, now next is an bending. So in a bending you can see some of the sorry, in the bending you can see this is also in cold working over here. If you have seen, if you go for the civil side, that is a construction area. Okay, the centering is been done for the slab concrete. This centering is been done with steel rods. Okay, these steel rods are been bent in a 90-degree or any of the angle with the help of an hammer blow. Okay, for that types of bending or the sheet metals you can see there are be bendings. Okay, and different bending procedure methods are there. According to that method the workpiece is been bent to get a desired assembly or in any of the finished products. Okay, such types of bending phenomena is also comes under the forging. Okay, over here the workpiece is not extended or forming in the forming the workpiece is not extended, but the shape of the workpiece by the bending is been made into an assembly work. Okay, now the roll forming. So the roll forming is nothing but in a cold working. Over here also the same hot rolling, how does it works, only the same way the cold rolling also is being done. Only the change is that the workpiece which is passing between the two rollers is in a cold condition, it is not in an hot conditions. So see, one more important thing, that the cold working conditions only can apply easily for the ductile materials. Okay, in a hot working, the hard material is converted, is allowed to change its property, okay, below the recrystallization, sorry, above the recrystallization, so the property changes, okay, of an hard material, so that it can works on a hot working condition. In a cold working condition, if the material is brittle, okay, it you can follow the cold working condition in the forming way. Okay, so these are the simple forming methods. Now next we'll go with the machining. In a machining there are two types, conventional and non-conventional machining. Okay, in a conventional machining there are four types: turning, milling, grinding and drilling. Turning, milling, grinding and drilling. So you have seen the turning also, you operations, you have done the turning operations, you are having the experience of turning operations in the third semester. Okay, so the milling also you have undergone, for the grinding also you have seen, and the drilling also. So all these four machines you have seen, and how these operations are carried out also you have seen. Okay, so why it is called as a conventional machining? Because in the conventional machining the for cutting tool is been used for the removing the excess material from the workpiece, or you can say the unwanted material from the workpiece, or the raw material is to be converted into finished products by removing it excess material into an proper dimensions. Okay, and different types of operations are being carried out for making an output from that particular part of that workpiece. By the milling you are putting in gear cuts, okay, by the turning the flat round circular surface, by grinding a flat surface and smooth surface, by drilling putting in holes or tapping you can do, okay, for the threading purpose. Okay, these are the different types of operations which are being carried out by the solve machinings or the turning operations in the conventional machining. In the conventional is nothing but where the hand cutting tool is being used for removing the excess material. Now next is an conventional machining. In unconventional non-conventional machining, so the non-conventional machining is nothing but the advanced technology of an conventional machining. Okay, in non-conventional machining, where the hand tools are been not used over here, so the different source of energies are being used for the cutting of an workpiece. Okay, so let us see which are the different sources. So see, you can also classify the machining or distinguish machining into two types. Okay, conventional and conventional, non-conventional, traditional and non-traditional. So see, the conventional machining is a traditional machining from the ancient times, from a long from we can say from so many decades. Okay, from so many decades these types of machining is been carried out, still now also it is been used. Okay, now further these machinings are been modified for the better improvements, okay, of the machining quality into an non-conventional machinings. Okay, so these machinings are called as an non-traditional. Apart from that traditional we are doing something different, so that is called as a non-traditional. Okay, non-conventional machinings. Okay, so the laser beam machining, electro polishing, ultrasonic machining, water jet machining, and electro discharge machining, electrochemical machining. So these are the different types of machining which are being used for machining purposes as a non-traditional way. So the laser beam is there over here. The laser light amplified rays are being used uh, for the machining purpose. Okay, light energy is being used over here, or the rays radiation are being used for the machining purpose for removing the excess material. Electro polishing. Okay, so electro beams are being used over here for the polishing. Ultrasonic machining is being used. Okay, water jet ultrasonic machining is being used. Okay, now water jet, high pressure water is been supplied on the machine, okay, for the cutting purposes. Okay, now next electro discharge machining is been used. Okay, so here the electronic discharge, electrons are being discharged. Okay, electrons or small electrons are being discharged by the help of the cathodes and the anodes. Okay, by which they have been discharged on the workpiece in a rapid way with a common lens is there from where all the beams are been electrons are been concentrated on a single uh, lens from where they are discharged on the workpiece at a single point. So these are some of the non-conventional methods which are been used for machining purpose. Now joining, permanent joining process and the temporary joining process. In permanent there are two types, welding, arc gas welding, and the rivets. And the temporary there are different types of processes are that's are the bolts, nuts, soldering, brazing, advisory. So these are the different joints. Okay, in the previous class also I have explained. So this is what the some of the classification of the manufacturing process. Now we'll go in the next concept. Introduction to the casting process. I think it is also been finished the classification. Often foundry alloys. So see, this is also one of the important thing is that the factors determining selecting the casting alloys, on what basis the casting alloys should be selected. So first one is an, so there are so many particular factors are there that has to be considered while selecting the casting alloys. Now you can see first one is an material properties, second one is on melting properties, okay, and third one is on casting properties. Okay, so what do you mean by the material properties? The materials possess their own sets of properties like strength, toughness, ductility, okay, corrosion, resistance, etc. Okay, so each and every materials having their own mechanical properties. Okay, and on that basis the casting alloys are being identified. What do you mean by the alloys? The composition of the two or three metals to achieve an mechanical property. When the strength and the durability is major requirement of the casting, the steel and the cast irons are the extra. When the strength and the durability is major, the requirement of the casting steel and the casting irons are the best choice. Further, when the corrosion resistance is an additional factors, okay, so the corrosion resistance is additional factor means what? The when the casting has been removed, when it comes to the contact with the moisture, okay, it comes to the contact with the moisture. So what you can say over here, there is an exothermic reactions occur by which the corrosion chemical reactions occurs by which is called as an corrosion or the rust. Okay, so that has to be avoided, or the major requirement is been done to resist, to stop such types of corrosions. Okay, so some of the alloys are being added during the furnace charge so that it can be utilized for the proper sound casting. We can get the proper sound casting for an automobile. For an automobile, Ravi, Ravi, for an automobile and aeronautical applications where the weight is a negative factor, the non-ferrous metal, especially aluminum, is preferred due to its comparatively high strength and weight ratio and also been corrosional resistance. Okay, so see, in the automobile sector, if you are using any casting products or the engine which has been made by the casting, so the main factor is to be considered that the lightweight should be there. Okay, if it is a non-ferrous metal, especially the aluminum is preferred due to its comparatively and high strength to an weight ratio and also being the corrosion resistance. Okay, so this are the things which has to be considered when you are selecting the material for the casting purpose or to get and finished products by these casting methods. Okay, now the melting properties. The melting point of the steel is greater than the cast iron. This adds complexity in the terms of choosing the types of furnaces. Okay, the melting procedure like and minimizing the gas absorption and dross formation evaluates the temperature, controlling the solidifications for the obtaining a sound casting, and the most importantly the cost involves in achieving the good melting. The different grades of materials have a different melting point and such as a proper choice is made with respect to its criteria. Now see over here what is happening if you are choosing an any of the product for the casting purposes. Okay, so that raw material of that means metal, either it may be the ferrous or the non-ferrous metal. Okay, so it is very difficult to choice the furnace. Okay, if it is a non-ferrous, so the furnace in a lightweight or the light capacity furnace you can use. If it is a no ferrous material, so if you go for the faster heavyweight furnaces where the heat is releasing more, the temperature can gradually increases. Okay, and makes the materials to melt over there. Okay, so this is how the workpiece material starts to melt. Okay, and the melting properties are being utilized for the identification of the furnace. Okay, or the selection of the furnace during this casting processes. So this is also one of the important factors that has to be determined while selecting the casting alloys. Okay, so if you are using the steel, okay, in the cast iron, if you are using a cast iron in any of the thing, so the capacity of the furnace, okay, that can reach that particular melting point of that particular alloy is to be identified and it is to be checked. Okay, before selecting the alloys. Okay, so this is melting property plays a very important role in the selection of an metal, sorry, selection of the casting alloy. Now next we'll go with the casting property. The metal used for the casting are the characteristics by their casting properties as listed below. The fluidity of the molten metal. The cast irons have excellent fluidity compared to steel. Okay, solidification shrinkage, volume shrinkage of an cast iron is a small compared to steel and the non-ferrous metal. The riser designs becomes a simple and smaller, leading to high. Okay, so the solidification shrinkage or the volume of and shrinkage of the cast iron metal is small compared to the cast iron. So these are the some of the casting properties are there that also factors. Okay, very much wild, we can say Selection of an casting alloy. So see the volume shrinkage of the cast metal is small compared to the steel. So you can go for the preference for the cast iron compared to the steel. Okay, and also compared to the non-ferrous metal. If the cast iron can fulfill the properties of required product by the casting, so you can go for that. Okay, so this is what the selection is done on what alloys you are going to use, how much volume it is going to be shrink. Okay, so these are the factors. So the riser design becomes a simple and a small, leading to a high casting yield. So see the risers which has been designed, okay, that is also gives to the high casting wheels. Okay, casting yield means what the breaking points. Okay, so these are the some of the factors which has to be considered during the cast selection of the casting alloys. Okay, so dear students, in the next class we will go with the another concept of the first module as a revision. Okay, so I will wind up my class today over here only. Okay, now over here also there are two factors are there. Okay, that is in cost and the availability of the metal. So see, while selecting the casting alloys, so this is the two important thing is that either the alloys are uh, costly or cheaper as per the casting rate. Okay, so the alloys selection has to be done. The cast iron is typically cheaper in terms of the material cost. Okay, energy and the labor is required to produce the final products. Okay, compared to the steel is very costlier. Okay, as per the non-ferrous, if you are going as an using as a casting alloys, the cost of that is also very costlier. Okay, now the availability of the metal. So whatever the selection of the metals you are making as an for the cast, so that availability also you have to identify and check either it can be easily available, so how the term of the availability means that the longer terms you can get the finish of the raw products. Otherwise don't prefer such types of costly and unavailable alloys as in casting products for the finishing purpose. Okay, so these are also the both factors are also determines plays a very important role for the casting product. Okay, so let us see in the next class. I will wind up over here. Goodbye students.